Yes, today's topic is differential equations. This is how we write down a differential equation. Actually, this is the easiest case of differential equations. We give it has a special name. The name is they are separable differential equations. Why? Because we can collect the terms with respect to y on one side, and we can collect the terms with x on the other side. Say that fy dy is on the left hand side and f of x dx on the right hand side, and it is easy to do the integration to get rid of the differentiation signs, and this is called the general solution. Why? Because at the end we are going to have a plus c, which is the integration constant. If we have the boundary conditions, which means if we know a particular x which gives a particular y value, that gives us, if boundary conditions are given, then we obtain the particular condition or particular solution, which means c value, the integration constant can be calculated. If the question wants you to leave c in the answer, it is the general solution. If values are given so that you can calculate and get the c value, the integration constant, we call it the particular solution. Let's see an example, an easy example to show what we can do about differential equations. Say that as example 1, dy over dx is equal to 6x over 3y squared plus 4, and the question is find y in terms of x. So it is easy to, let's rewrite the question, put 3y squared plus 4 there with dy, and take the x there, then do the integration, 3y to the power of 3 divided by 3, 4y is equal to 6x squared divided 2, and you can put only one c on one side. You don't need to put a c there and another c there. So we obtain that. Find an equation in terms of y and x is the question, and is equal to 3x squared plus c is the solution. That's it. So easy. Any questions? Checking the messenger. I hope you don't have any questions. This was the easiest one. Now, let's carry on with example 2. In example 2, I am going to I'm going to give you a case which is a little bit special. You have to be careful about C. And in this question, we are not going to have a C. Instead of the integration constant C, we are going to have ln K. Because in the answer, you are going to see that all the solutions are going to be in the form of ln. And if all the answers are in ln, instead of C, we put ln K. Let's have such an example. Say that dy over dx is equal to 2x plus 1 and 2y plus 5. Or doesn't matter, 5. 6. Make it 6. Okay. And it is given that when x is 4, y is equal to 5. So, find y in terms of x is the question. Now, here, when we have dy over dx is equal to 2y plus 6 and 2x plus 1, let's separate them, put all y's on one side and put all x on the other side. I am going to take this 2y plus 6 to the left hand side. And take the x there. So now we need to do the integration. What do we have here? We have 1 over 2y plus 6 dy, and on the other side we have 1 over 2x plus 1 dx. And remember, if we have 1 over ax plus b dx, the answer is 1 over a ln ax plus b plus c. This is the information that we have to know to be able to find the integrations there. So what are the integrations? We have 1 over 2y plus 6, and using that identity here, the answer is going to be 1 over 2 ln 2y plus 6 is equal to, here with the integration of this one is 1 over 2 ln 2x plus 1. Now in this case, because all the terms are all the expressions are here are in terms of ln, so instead of c, I am going to put ln k instead of the integration constant c. Because all the terms are written in ln, I am going to put ln k. So, what is the meaning of 1 over 2 there? Means I can put it as square root. And again, I can take that one as the square root, as the power of that expression. As the power. And we have ln k there instead of c. If we have plus there and if we have ln's, that means we can multiply them and has a single term with ln. have sufficient information there given as boundary conditions so that we can obtain a particular solution. Now we have sufficient information there given in the question to have the particular solution, which means actually we can find a value for k. So we know that when x is equal to 4, y is equal to 5. So when x is equal to 4, y is equal to 5. That is given in the question. Ln 2 times 5 plus 6 to the power of 1 over 2 means the square root is equal to ln k times 2 times 4 plus 1, 1 over 2, ln 16, 1 over 2 is equal to ln k times 9 to the power of 1 over 2. That means ln 4 square root of 16 is 4, very easy. Ln k times 3, because they are equal to each other, 3k is equal to 4, k is equal to 4 over 3. So let's write down the particular solution. Ln 2y plus 6 square root is equal to ln 4 over 3 2x plus 1 square root. So all of them are under ln. We can cancel ln's here. 2y plus 6 to the power of 1 over 2 is equal to 4 over 3, 2x plus 1 to the power of 1 over 2. Let's square both sides. 2y plus 6 is equal to 16 over 9, 2x plus 1. That means y is equal to 16 over 9, 2x plus 1 minus 6 multiplied by 1 over 2. That's the answer for the question. Okay? Let's add pictures of the solution if you need it. Now I am going to clear the board to have some space for another couple of examples. Let's have another example. Example 3. Find x 1 plus x squared to the power of 6 dx. Part B, as you see, this is not a differential equation, but now in part B we are going to have a differential equation to solve, and we have, as you see, the boundary conditions to have the particular solution. And that's the differential equation to solve. I made up this question, so we may have extraordinary answers. So, for part A, we have x 1 plus x squared to the power of 6 dx. Here, it looks like that we can use by parts to solve it because we have x there. But as you see, the derivative of this one, that term here, 1 plus x squared, is look like x there. So I prefer substitution here so that we can find this integration. I am going to use u is equal to 1 plus x squared as a substitution so that we can find this integration. Let's see how. Du over dx becomes 2x. And du is equal to 2x dx. Let's have a manipulation here. Let's change the places of this one. Here, if we change the places of that one, it is easy to see that 1 plus x squared 6, and we have x dx there. And we can put that one we can obtain x dx in terms of u here. As you see, that one becomes du over 2, and this is u. So u to the power of 6, x dx is du over 2. So take 1 over 2 outside of the integration. We have u to the power of 6 there, du. So the answer is going to be 1 over 2 u to the power of 7 over 7 plus c. So the answer is 1 over 14 u to the power of 7 plus c. And u is what? U is here. It is 1 plus x squared, 1 over 14, 1 plus x squared to the power of 7 plus c is the answer. Now I solved it with substitution because I recognize that when I take the derivative of that expression here, 1 plus x squared, it gives something like x. Actually, it is 2x, but we can leave x alone by taking 2 there. So if we can easily see that we can find x dx in the question. That's why I use substitution. Now, part B of the question, dy over dx is equal to x 1 plus x squared to the power of 6 cosine squared y. That's a separable differential equation. Put x's on the other side and y's on the left hand side. Dy over cosine squared y is equal to x 1 plus x squared to the power of 6 dx. Put the integration signs. What is cosine square y? What is 1 over cosine square y? Sec. So actually this is sec squared y dy. And do we know the integration of this one? Yes, it is already there. We found the integration of that one in part A, so I am going to write the answer directly there. 1 over 14, 1 plus x Yes, sorry. Sorry for the connection problem. Again, I separate the y's and x's. In terms of 1 over cosine squared, I wrote down sec square y, and we have the answer of that one in part A. I wrote down the answer, and we know the integration of sec square, it is tan y is equal to 1. Yes. When y is equal to pi over 4, x is equal to 0, given in the question, tangent pi over 4 is equal to 1 over 14, 1 plus 0 squared to the power of 7 plus c, 1 is equal to 1 over 14 plus c, so c is equal to 13 over 14. That means tangent y is equal to 1 over 14, 1 plus x squared to the power of 7 plus 13 over 14 is the particular solution. And I'm going to give you an example, and we have a story in that example. Let's write the example down, but before that, I'm going to send the picture of the solution to you. Yes. Let's erase the board and write down the fourth example in the last one. This is the last, it is a little bit long question, sorry about that. It has a story. The rate of temperature loss of an object is proportional to difference between the temperature of the object T and the room temperature. The room temperature is constant to 20 degrees centigrade. Yes, the question is on the board. The rate of the temperature loss of an object means we have a rate of temperature here. It is loss means the rate is negative. To the difference between the temperature and the room temperature, which is -20. So the rate is negative, is proportional, so we have to have a proportionality constant to the difference between the temperature of the object and the room temperature. We have the difference there. So this is for part A. You have to mention that the loss is negative and it is proportional, and I use lambda as the proportionality constant, and we have to mention that we have a difference here between the temperature of the object and the temperature of the room. Now, to be able to find T in terms of small t there, temperature in terms of time, we have to differentiate. How? Let's see. We have dt over dt is equal to minus lambda t minus 20. Here, I'm going to take t minus 20 there and dt there to separate the differential equation. So we have to take the integrations. This is going to be ln, and we have to put minus lambda t there, and we have to have a constant. Say that it is c, integration constant. So ln means logarithm to base e. Take e as the base of that expression here. So t minus 20 becomes e to the power of minus lambda t plus c. And we can separate them. T minus 20 becomes e to the power of minus lambda t times e to the power of c, because we have addition there. So again, change their places, e to the power of c times e to the power of minus lambda t, and say that a is equal to e to the power of c because it's just a constant. So t minus 20 is equal to e to the power of c, that is a, times e to the power of minus lambda t. Take 20 there, t is equal to 20 plus a e to the power of lambda t. That's the way to show it. And for c, part c, we have additional information there so that we can find the value for lambda. And we know that after 5 minutes, t is in minutes, temperature is going to be 70. Find the value for C. We have to find the value for lambda. But before that, we have to find the value for A. And we know that when T is equal to 0, temperature is what? 80. So let's use that one. 80 is equal to 20 plus a to the power of a times e to the power of minus lambda times 0. E to the power of 0 is 1. So 80 is equal to 20 plus a is equal to 60. And substitute there. So temperature is 20 plus 60 e to the power of minus lambda t. Now it's time to use that information so that we can calculate the value for lambda. We know that when t is equal to 5, when time is equal to 5, temperature is equal to 70. So 70 is equal to 20 plus 60 e to the power of minus lambda times 5. 50 is equal to 60 e to the power of minus lambda 5. 50 over 60 is equal to e to the power of minus 5 lambda. And if we have an unknown on as a power of e, we have to use ln. ln 5 over 6 instead of 50 over 60, I use 5 over 6 is equal to ln e to the power of minus 5 lambda. These cancel each other. ln 5 over 6 is equal to minus 5 lambda. So minus 1 over 5 ln 5 over 6 is lambda. Do you have any questions? Checking my phone for your questions. No questions, so I am sending you the answer and finish the lesson. Yes. Actually, we have finished P4 on Monday. Hopefully at 6 o'clock, if we survive from this virus thing, we are going to solve. Let's take that book here. I am going to solve the exam practice at the end of your P4 book. On Monday, I am going to solve this one for you. The exam practice at the end of the book P4. Have a nice weekend. See you later.